A stone of mass 0.25 kg is tied to the end of a string, which is whirled around in a circle of a radius 1.5 meters with a speed of 40 revolutions per minute in a horizontal plane. What is the tension on the string? What is the maximum speed with which the stone can be whirled around if the string can withstand a maximum tension of 200 newtons? We know the frequency, that is 40 revolutions per minute, that means n is equals to 2 by 3, and we also know the formula for our angular velocity, that is omega is equals to 2 pi n. By Newton's law of motion, we know that the centripetal force is equal to the tension on the string. So mv square by r, which is the centripetal force, can also be written as m omega square by r, as omega is equals to velocity by radius. Now putting the values which we already know in the given question, we get the tension on the string as 6.57 newtons. Now we are given that the maximum tension is 200 and we need to find the maximum velocity. With this formula of centripetal force is equals to tension, we can get the velocity, we can get the maximum velocity as a root under maximum tension into r by the mass. Therefore, by putting the values, we get the tension, or we get the maximum velocity with which the stone can be whirled is 34.64 meter per second.